Hello there. So last time we talked about these formulas for the mean and for the amount of variation within our data set. So how different are each of our values from the mean. Since the formulas for the mean are so simple, they're just take all your values, add them together, and then divide by your number of values. I'm going to leave those alone. Where I'm going to give my attention is down here on our formulas. However, instead of just going through each of our formulas, I'm going to go ahead and break these down into the individual components, or at least the components that are confusing enough to warrant being included. So let's take a look through here. This is somewhat unfamiliar. So let's take this as our first formula chunk. We're going to have the sum of x minus mu squared. That's a good one. Let's look over here. These are two more components that we aren't quite familiar with. I'm going to put this one next. We're going to take 2, so n times mu squared. Then the third one from that same formula, the sum of x squared which we'll see appears down here as the sum of x squared over n. So we can put or the sum of x squared over n. Then we come on to our next piece. We could look at this, mu squared. However, that's just the mean squared. Well, I'm going to assume that that is familiar enough for you that you don't need me to go into any detail on this one. We have 1 over n, which is just 1 divided by the sample size. I'm also going to assume that that is familiar enough to you that I don't need to go over it. And I'm going to come over here to the sum of x inside parentheses squared divided by n. And then let's see. We'll take a quick look through here. Nothing there. And then these formulas are just the formulas from this first page, but for sample statistics instead of population parameters, as indicated by S instead of omega. Whoop, got me again. This is S instead of sigma. There we go, lowercase sigma. So, how do these different components of the formulas work in? Well, let's draw a line off. I think the best way is to go through with some sort of data set. Let's go with something that isn't a multiple of 5. So let's say 3, 3, 5, 8, 10, and 13. That's a set of 6. That adds to 42. And 42 divided by 6 is calculating our mean, means that mu is equal to 7. That's pretty good. No multiples of 5 in either our total or our mean. I can work with that. So how does this work? Well, in coming down to the first fragment, we have the sum of x minus mu squared. And really, this isn't a fragment because this calculates the sum of squares, but it is a fragment of these later formulas where we have it divided by n, or the square root of it divided by n. So let's go on and start calculating. So we're going to take x. So what's x? X is this set of values up here. Each of these is x. So we're going to have 3, we'll mark this step 1. We're going to have 3 minus mu. What was mu? 7. So 3 minus 7 squared plus 3 minus 7 squared plus 5 minus 7 squared plus 8 minus 7 squared plus 10 minus 7 squared plus 13 minus 7 squared. Just enough room for that. Glad I didn't go any bigger. So, what's our second step? Well, following order of operations, we're going to take care of what's inside here first. So it's going to give me negative 4 squared plus negative 4 squared plus negative 2 squared plus 1 squared plus 3 squared plus 6 squared. In step 3, we're going to be squaring these. This is an important step because it gets rid of the negatives, letting us deal with the absolute value. So this will come up with a sum that is not 0. Because if we just added all these together, I mean, we have negative 10 on this side and positive 10 on this side, we just end up with 0, like I showed in the last video as an example. So we end up with 16 plus 16 plus 4 plus 1 plus 9 plus 36. What does that sum to? Well, we have 16 plus 16 plus 4 plus 1 plus 9 plus 36 is equal to 82. So if you're going through and calculating this, the sum of squares for this set of variables is equal to 82. Not bad at all. Let's go on to our second piece of the formula, or our second formula piece, since these are from different formulas. So we have 2, so this is n times mu squared, which I could also write as n times mu squared, just to help me remember that I'm multiplying and that these are separate terms. So step 1, what do we got to do? We've got to take all these stand-ins and replace them with our numbers. So n was equal to 6, so we can take 6 and we need to multiply that by our mean squared. What's our mean? 7. So 7 squared. Let's go over here. Second step, we're going to keep our 6. Going with order of operations, the exponent comes next, which gives us 49. Because 7 squared, or 7 times 7, is 49. Then we go on to our third step. We're multiplying these two together. We get 6 times 49 is equal to 294. Not bad. So that is the answer for this data set on this piece of our formula. We're going to need a new page to handle our next set of the formulas. We're going to take the third one, the sum of x squared, and I'll just do the over n version for you, just so you can see that extra step. So what do we need? This is saying we take each of our x's, square them, and then add them. So we can do that. Where are our x's? Well, we had 3, 3, 5, 8, 10, and 13. We need to square each of these and then add them. So what does that give us? Well, that gives us 9 plus 9 plus 25 plus 64 plus 100 plus 169. And in step 3, we just sum those together. So we have 9 plus 25 plus 64 plus 100 plus 169 is equal to 376. Now, we're doing this, if we were doing the normal just sum of x squared, this would be our answer. However, I said we would be doing the divided by n version, so that extra step. This means that this is not really our answer. This is just the penultimate step, the next to last step. what I need to do is to go in and remind myself that I'm dividing by n. In this case, since I have 6 pieces of data, 6 values, I'm dividing by 6. If I had 10 pieces of data, I'd be dividing by 10. So I need to go in here and add these. I just avoid doing this as I'm running this formula because I've run it so many times that I don't need it there to remind myself what comes next. But it is important as you're getting started, or if your professor wants you to show all steps. So what is this equal to? Well, let's take it down to a 4th step. So 376 divided by 6 is equal to 62.666667. What I'm going to round to 0.67 because I want to keep only 2 values to the right of the decimal point. All right, now we can head on to our 4th piece, which was, in parentheses, the sum of x squared over n. And let's not forget that line to separate these areas. So what are we doing? So we're taking x's and summing them. So this would look like 3 plus 3 plus 5 plus 8 plus 10 plus 13 squared. All of that over 6, because that's how many pieces of data we have. However, we can skip this step because we've already calculated this information when we found our mean to do the earlier chunks of formula fragments. So I know that this is going to sum to 42 squared over 6. Then we go on to step 3. Well, 42 squared is equal to 1,764 over 6. And if we go ahead and divide by 6, as in step 4, we come up with the answer of 294. So that is the answer for this piece of our formula. We'll go ahead and box that, and go ahead and box the one I missed up here. So there you go. Those are the 4 essential chunks to looking at and solving these formulas. Let's go ahead and just run through one of these just so you can see how it would work out. Let's choose one with all the different steps. So let's say this formula here for the standard deviation of a population. And we're going to use the computational version of it. So what do we have? Well, we're looking for the standard deviation, so lowercase sigma, is equal to 1 over n times the sum of x squared minus the sum of x squared over n. Put that in brackets. So what are we going to do? We're just going to take this formula and start substituting in our values. So we're going to have 1 over n, which is 1 over 6 because we have 6 values, like we see over here. Then we're going to put our bracket in. We're looking for the sum of x squared. Well, let's see. Where did we solve that? The sum of x squared the sum of x squared is we don't need over n because the n is taken care of on the outside of this formula, as you can see there. So we're going to go ahead and find that on our second page, which would have been step 3 is where we would have stopped if we needed just sum of x squared. So we have 376 minus sum of x squared divided by n, which was this piece. Sum of x squared divided by n is equal to 294. So we'll take care of what's in the brackets first. We have 376 minus 294 is equal to 82. which gives us 1 over 6 times 82. Now I'm going to go ahead and figure out what this is. So 1, put this in the frame for you, 1 divided by 6 is equal to 0.167 if I were rounding, times 82. 0 my calculator, so I can put in exactly what I have written down, so 0.167 times 82 is equal to 13.694, and we're almost there. If you've been paying really close attention, you'll realize I forgot to include something in this formula over here. I forgot to include our square root. So really, all of this should be under, as should this, as should this, and this, and this. What I've calculated here is my sigma squared, my variance. I've essentially done this formula. You can see right there. However, I said I was going to go out and calculate this one, which is why I've added in my square root sign now that I've realized I've forgotten it. Which means I'm going to go in and I'm going to find my square root, which is going to tell me that my answer for the standard deviation for this sample is 3.7. Now, this is not truly a population, even though I'm using the formulas for a population. It's just so you can get familiar with these. Now, we would technically need to use the sample versions of these. It's what we have on this page. So where we're using s and lowercase n and x bar in the place of sigma, capital N, and mu. However, the formulas are built the same way. The only difference is if we were to do an unbiased version, in which case we just have to see where we're using n minus 1 or degrees of freedom instead of n. So there you go. That is how you solve the 4 sort of component pieces of these formulas and how you run them through to calculate your answer. I hope this has been helpful for you. Let me know if you've got any questions about what's going on here, if there's something you'd like me to cover next. And you can find all of these linked to down in the description.